All right, taking a look at example 2 here, where we're going to end up with an answer with two real roots, where in this case our c term is negative. So if you look at our c term, that would be the negative 17. If we use our quadratic formula, it is as easy as plugging in those values for the a, b, and c. You'll see that in the second line. Once you have done that, you can reduce everything inside the radical to the 84 that is written. Then we break up the square root of 84 into whatever perfect squares we can find. So we can find a factor of 4 in there. So we end up with the square root of 4 times the square root of 21 in that fourth line down, where the square root of 4 is then turned into just 2, which is why we're looking for those perfect square numbers, so that we can find those radicals that simplify down into an integer. Okay, finally, we end up looking at something that looks like negative 4 plus or minus 2 root 21 all over 2. So we divide both sides of the top of the fraction. The negative 4 gets divided by 2, and the 2 root 21 gets divided by 2, giving us the final answer of just negative 2 plus or minus the square root of 21. So one of our real answers is negative 2 plus the square root of 21, where our other answer is negative 2 minus the square root of 21. Imagine real quick what you think this graph looks like, and if the graph that you imagined looks like this, then you are on the right track. We are looking for one where c is negative, which means that if we think about this, looking at our original equation, x squared plus 4x minus 17, we need to have a situation where if we plug in 0 for x and those first two terms go away, we're looking when x is 0, all that should be left over is our c term, which is our y-intercept, negative 17.